Okay, so we're going to do that. Hello, Mia.
Hi.
How you doing?
Good.
Right. Did you get a chance to do the homework? The homework, the Unit 1 test.
I finished it, but I forgot to turn it in.
Okay, that's great. Just, yeah, turn that in today. Okay, we're starting with the new unit. Now, the unit, we are going to learn about polygon. Now, the polygon actually made of two words. Uh, poly, just like in other time when we say poly, it just means many. And gon just sides. So polygons has many sides. Well, the simplest one we have is triangle, which have three sides. Sometimes they call that, we call triangle, kind of interesting. We are not using, we're just talking about the angles. There are three angles we call triangles. But sometimes people can call that three-gon. Okay, uh, not popular, but sometimes people call that. But the interesting part is only the triangle we use the angle, which is three angles. Basically, that triangle means. Anything above that, we actually just talk about sides. Even though you can say the same thing, you can say, like, say, a square. Square is quadrilateral. Quadrilateral means four sides. You can also say that quadrangular. Um, Nothing wrong with that, but it's not popular. And well, so we got a triangle and we got quadrilateral. And after that, fortunately, we just call them gons. So like the pentagon. So there is a famous building that defense department is shaped as a pentagon shape. So we call it pentagon. Pen just means five sides, penta. And then the next one, so we got triangle, three sides. And we got quadrilateral, four sides. Then we got pentagon, five sides. And of course, we got hexagon. Hexagon is six sides. Then we got heptagon. Heptagon. That's seven sides. Of course, we can get more than that. Normally, once we got to about 12, then that's where we stop. You can keep going, but normally we just stop there. So eight sides, we call that octagon. Octagon. So when we have the calendar, we call October. Actually, in the original calendar, this is the 10th month. Sorry, eighth month. October means eighth month. But the Romans sneak in 2 months between the 7th and the 8th. So the 2 months they sneaked in is June and July, 2 J's. They sneak in two. So therefore, the October become 10th month. Originally is 8th month. November actually should be the 9th month, but now become the 11th. And December, well, that should be the 10th month, but now become 12. Just all because the Romans sneak in 2 months. One is for Julius Caesar, one is for Augustus Caesar. So they sneak those in there. That's why we see that kind of off in our calendar. Okay, octagon, eight side. And then the ninth side, kind of like November, but they called Nolagan. Just think about October, November, instead of the months, just say octagon, ninogon, and that's 9 sides. And kind of like December, we got called decagon, and that's 10 sides. And of course, we could have, there is Udagon, which is 11 sides. Normally we don't talk about it, but the other one is dodecagon. Now you probably learn some Spanish. Unos, dos, uno, udagon, dodecagon. So it means the DCA, of course, that's the 10. This is a 10. So this is a 110, which is 11. This is 210, 111. And that's how this used to say numbers in the old time. They actually call the unit digit first. Now, back then, when you say how old you are, like say if you're 21, you'll say 1 and 20. That's what the British used to say. They call the unit digit first. So we had those polygons, but the first one we're going to study is actually the simplest polygon, which is triangle. Now, what we want to study triangle, the one thing we want to learn about triangle is their relationship. Okay, so that means between two triangles. And there's two things we're going to learn. One is called congruency. Congruency in geometry, basically this means equal. Yeah. Well, we know the geometry came from the ancient Greeks. So there's a lot of Greek influence on the name we have. So instead of say equal, we say they are congruent. And that means two shapes. So we got two polygon, or could be any geometric shape. So that's two shapes have the same sides. That means they have the same area and same shape. Sometimes you can have the same side, but not have different shapes. For example, if you look at triangle, this triangle, and well, here is the parallel line between here. So they have same height. And this triangle have exactly same area. Even though the second one looks probably not as big as the first one, but they're actually the same because we know the area formula is half base times height. Now we have the same base, we have the same height. Height is from here to the bottom, from here to the bottom, same height, same base, same area, but they are different. The shape is different. So when we talk about congruency in geometry, we're talking about those two shapes not only have same size, also have same shape. So like say, for example, if we have these two, let's assume they are the same size and the same shape. So those two, we call they are congruent. So these two triangles are congruent. So now there is a ways to do incongruency. And there's some theorems we're going to learn. So the first theorem, so this is our second unit, the first theorem. This we call that side theorem. So SSS, that means if two triangles have the sides, like this side is corresponding to this side, and this side is corresponding to this side, have the same length, then this side and this side have the same length. So we got this side is the same length on this side is same length on this side, and this side same length on that side. So we call them, those are congruent. So as long as three sides are have equal sides, respectively, like the corresponding sides are same length, so that we know they are congruent. So this is called side theorem. Okay. And then we have theorem 2-1 is called side angle side. Sometimes we don't need to know the three sides. We just need to know two sides and the angle between. For example, if we got a triangle like this, now if we just know that this angle, this side, and this side are congruent, and also this side are congruent to this side. And also their angle between those two sides. So this angle we're talking about, that's why we put the angle in the middle. So this angle are congruent. So therefore, these two triangles are congruent. So this is called side angle side theorem. And we have, this is a 2-3. 2-3 is called angle side angle theorem. Okay, like here, 2-2, we need two sides. On 2-3, tell us we just need two angles and the side that between the two angles. So for example, if we know this angle and that angle are congruent, and we have this angle and this angle are congruent. So it's two angles are congruent. And the side between those two angles, if they are congruent, and then the triangle is congruent. Now we have the last one, 2-4. This is called angle side angle theorem. No, angle side, not. So in this case, we got two angles and the side, which means we don't have to need the side in between angles. If this side and this side are congruent, now this is angle side. Well, it could the side angle, but this is a convention. We just call the angle side. Now this one actually is a simple case from this theorem. So sometimes they put this together as one, because if this angle and that angle, the red angle, the black angle are congruent, the blue angle are congruent. So therefore, because all three angles add together has to be 180, so therefore this angle is automatically congruent. And now you can see we actually got angle side angle. So actually it basically is a kind of variant from the theorem 2-4 is a variant from 2-3. Okay, are we any questions here? Okay, so we are good on that. Yeah, pretty straightforward on this one. Okay, now we're going to learn a little bit kind of the convention notation, like what do we mean? What do we call? There is convention to it. So therefore, when we talk about two congruent triangles, we have to make sure all the angles match and all the vertices match. So if we call this ABC and ABC, DEF, which means that if those two quadriangle ABC is congruent to triangle DEF. When we say right like that, we meant this A and D, they can match. A and A, the angle will be exactly the same measure or same degree. And B in the second letter will match the second letter on the other triangle. So we're talking about this angle and this angle. And then F and C, they match. So we have this angle and this angle. Okay, so the very important, all the letters has to match. So that's why we say triangle ABC congruent to triangle DEF. If that's the case, then we cannot say triangle ABC is congruent to triangle FED because they don't match. See, the A actually should match to D, but out of order. So we don't do that. So everything has to match. Okay. Are we good on this one? Thank you, Mia. All right. Okay. Now we're going to doing some give some examples. But before we start with example, there is something acronym we need to learn. This acronym very useful, and it's called CPCTC. Now, what that means is corresponding, for C, corresponding parts. So the P is parts. So we got C here, P here, of course, we don't have to write O, of congruent triangle, congruent triangles are congruent. Okay, so first C from corresponding, P is parts, second C is congruent, and D is triangle, and then not C is congruent. So that means when you have two triangles that congruent, just we said early on, then all the parts are congruent. That means this side, if we say this ABC and DEF, if we say these two triangles are congruent, triangle ABC is congruent, triangle DEF, then AB has to be congruent, or AB equal to DE, same length. And BC has to be equal to EF. So that's basically the logic consequence from this fact. Those two triangles are congruent. And the AC is same length as DF, and of course the angles. Angle A we write as angle A congruent to angle D. Then angle B is congruent to angle E. And of course, angle C is congruent to angle F. So that basically this what means is if the two triangles are congruent, then all the corresponding parts means sides and angles are also congruent. Okay. Thank you, Mia. Thank you. Okay, all right. Now we're going to look at some examples. Click whiteboard. Okay, that a little bit bigger. Okay. All right. So today we're actually learning something called two-column proof. And this is typical in geometry, and kind of just make sure our thinking is clear and it's very logical from one thing to another. That's what logic means. One thing leads to another. So we actually have two columns. One column is a statement. So what we're trying to tell people. The second column is the reason we have. Okay, let's see how we do that. Now, for the first example, we said, given that E, which is here, is the midpoint of segment MJ. And the segment TE, so TE is perpendicular to MJ, so that's 90 degrees. And prove that triangle MET and JET are congruent. So that means we got two triangles. This side is going to be, we're trying to prove this side is congruent to this side. Well, how do we start? Well, we know we have those theorems. So first of all, see what we know. And the first thing we're going to say, the line length, ME, this one, is congruent to JE. And the reason tells why. Why? Well, because that's the definition of the middle point, because E is the middle point. So by definition, ME is equal to JE. So that's the first one. And we're trying to make either side, 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 or side, angle, side, angle, side, angle, 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 side. So that's what we're trying to get to. And then TE is perpendicular to MJ. Well, this is given. That's our reason, because right here you can see that the TE is perpendicular to MJ. Okay. And so therefore we know the angle MET, which is this angle, MET, that angle. That angle is 90. And also the angle JET, this side, this angle, is also 90. Now, this is because of the definition of perpendicular. This is what it means by perpendicular. When we say something is perpendicular, one line is perpendicular to another line, which means that the angle we make are 90 degrees. All right. And so what do we know so far? We know this side is congruent to this side. That's what we got is from here, the definition, I mean the point. And we also know that this angle is congruent to this angle. And that is because those two, TE is perpendicular to MJ. So this line is perpendicular to MJ. So therefore, we got the angle, this angle and this angle are congruent. And the TE is congruent to itself. This is called reflexive property. Reflexive property just means something is equal to itself, okay? Kind of like we say, me, give me this. So that I'm referring to myself. Now, T, we call this common side. So they are the same, congruent. So this by itself congruent. So what we got a side, angle, side. So therefore, the triangle should be, this actually be triangle, not angle. Triangle MET is congruent to triangle JET. So that's kind of how we prove doing the proving in geometry, okay? And that's something we are going to do quite often in this unit. Okay, are we good on here? Okay, all right. Now we're going to looking at a couple more, okay? Example 2, we have 5 examples, okay? Example 2, given that AB and DCD bisect each other, well, there's new word here, bisect. Bisect means cut something into two equal half. That's why there's a bi here. Sec means cutting. So cut something into equal side. Okay. So we say AB and CD bisect each other at that point M. And we're trying to prove that AD is parallel to BC. Okay. Well, let's see. First of all, we know that AM is equal to MP. Well, that's the definition of bisection. Okay, and also DM is congruent to MC. Well, we use this 2 ticks means they are congruent, and there's 1 tick just show that they are 1 tick and 2 tick are different. So that means AM is not necessarily equal to MC, but MC is equal to DM, and AM is equal to BM. So that's what we mean by using those ticks. Okay, that's first we got. And we know this angle, AMD, is congruent to this angle. Now, this is what we learned before. This is called vertical angle theorem. So all the vertical angles are congruent. Okay, so now what we got side, angle, side. So therefore, this triangle, AMD, which is, well, here now, is AMD, this triangle, is congruent to this triangle. Okay, because we have side, angle, side. Okay, now we prove that they are congruent. So if that's the case, then we know angle A should equal to angle B. So this angle, this angle is equal to this angle. Well, we need to make sure we got the corresponding, okay? Why we see this too? If you look at here, this left triangle is equal to the right triangle, and we can see how do we match? Well, if we use AMD, now the other match will be what? From A to M, and this AM is congruent to BM, so it has to be BM here. So that means BMC. So therefore, A is corresponding to B. So angle A is congruent angle B. Once we have that, one thing we notice, there is 2 lines here. One is this line, one is that line. Well, what happened to this line, A to B? We call that transversal. And we can see that these 2 angles, the green angles, are between 2 lines we call interior. And they are on the either side of the transversal. So that's called alternate interior angle. And they are equal. So therefore, based on the alternate interior angle theorem, this is what we learned before, angle theorem, then we know this line is parallel to this line. So that's where we end up proving AD is parallel to BC. Yep. We good on this one? All right, okay. All right. All right. Okay. The example 3, we are given PR bisects angle QPS. Where's the QPS? Q is here, P is here, S is here. So we're talking about this angle. And we see that PR is here, R is here. So PR is this line. We see this line bisect the angle QPS. That means this part and that part are the congruent. And we also know PQ, which is this line, that is congruent to PS, this line. So we know this and this are congruent. Now we're trying to prove that this angle is congruent to this angle. Okay, we're trying to prove that. This is a Q and this is S. Okay, let's see how we prove it. First of all, we're going to talk about what do we know. So first of all, we know QPR, which is Q, P, and R. So this angle is congruent to SPR. S here, P here, R here. We're talking about this angle. So these two angles are congruent. Well, that is basically the definition of angle bisector. We're talking about, that's given, the bisecting. Okay. And also we know the line PQ, this line, and PS are congruent. And that's given. Okay. And now we know PR, this line has to equal itself. This we call reflexive property. So therefore, we have side angle side. So therefore, based on side angle side, the triangle on the top, PQR, this triangle, that's congruent to the bottom triangle. This we just prove that, side angle side. Now, given that, then this angle is congruent to this angle. Well, because look at it here, Q matches S. So therefore, those two angles are congruent. The reason for that is this CP, CTC, because we know those two triangles are congruent, and the angle Q and angle S are the corresponding parts. So corresponding parts of congruent triangle are congruent. So therefore, we prove that. Okay, we good on this one? Yeah. All right. Yeah, make sure you follow every step, okay? That's very important. Once you can follow the steps, you'll be good, okay? All right. Given WX, where's WX? WX is here. WX is congruent to YZ, so this and this are congruent. And we know ZW is this, is congruent to XY. So we want to prove that WX, which is this line, is congruent to ZY. So we want to prove this and this. That's how we're going to prove. Okay, I'm going to use different color to show that that's something we're going to prove. Okay, we're going to prove this. Red is something we know. Okay, first of all, we want to say what do we know? That's basically WX is congruent to YZ. So we can't just repeating this, what's given. And ZW is congruent to WY, so that's given. And we know ZX has to equal to itself. So that is, we call reflexive property. So therefore, what do we know? Well, we have side, side, side. So therefore, based on side theorem, then the triangle ZWX, ZWX, so this bottom triangle is congruent to the top half part, this WXZ, congruent to that. Now, if that's the case, then we know the triangle XZ, YZX, YZX is this angle, and WXZ is this angle. Well, if we can step back to see what now we know, we'll clean this part up. Okay, now what do we know? Well, we see that this is two lines here, ZY and WX, and the two angles are inside the two lines, so that's called interior angle. And also we know this line here is the transversal. It's on either side of the transversal, so that's alternate interior angle. So based on alternate interior angle theorem, if these two angles are congruent, then we know these two lines has to be parallel. So that was how we able to prove those two lines are parallel. Okay, we good on this one? All right. Okay. So let's look at our last one. Last example, okay. Given CD is parallel to AB, CD is this one. I'm going to use red. CD is this one. AB is this. They are parallel, so this angle has to be 90. And D is the middle point of AB, so therefore this side and this side are congruent. We want to prove that CA, this line, and CB, we want to prove those two lines are congruent. So we're trying to prove this and this are congruent. Okay, so how we do that? Now, so far I can see the reason we're trying to prove, we prove some two triangles are congruent. Then based on that, then we use CP/CTC to prove that either the angles are congruent or the lines are parallel or lines are congruent. Okay, so again, the same starting point is what do we know? We know AD is congruent to BD, so that means AD is here, congruent to DB, that's the definition of middle point. And then we know angle ACD. ACD is 90 degree, and BDC is also 90 degree, and that's from the definition of perpendicular line. And we also know that CD is congruent to SOLVE. So now you can see we got a side angle, which is 90 degrees, and also the side. So that and side angle side. So therefore, this triangle is going to be congruent to the other triangle. Now, given that, then according to CP/CTC, then we know this side is corresponding to this side. So therefore, they have to be congruent. So that's how we prove that their congruency. Okay, are we good on this one? All right. Okay. Now, I want you to do some work here. First thing is write out all the congruency theorem? Okay, good. Okay, you just type out we learned 4 theorems to prove triangle congruency. So just write them out. Just use 3 letters, okay, to write out what they are. Well, remember what we learned about congruency? What's the first one? Because I have triangles. We have side and angles. What's our first one? How do we know those 2 triangles are congruent? Yep. Okay. Grayson, what about the first theorem?
Sorry, it's not showing the screen, it's glitching.
Okay, can you see it now?
Hold on. Oh, there it is.
Okay, well, what is our first one? First theorem to prove 2 triangles are congruent?
Oh, wait, wait.
Yeah, so when we're dealing with triangles, or any polygon, just side and angles. Well, the first one actually is side, okay? Side. So that congruent to that, this congruent to this, then this congruent to that, then these 2 triangles are congruent. Okay, how about the second one?
Wait, which second one?
What's the theorem? Second theorem. First theorem is side, side, side. Yeah, if you don't know, you can just type IDK. That's fine. Yeah, good job, Grayson. Mia? Okay, the second one is side angle side. Okay, that means we know this side this are congruent and this side are congruent, and also the angle in between. So that's side angle side. Okay, what's the third one? Okay, Grayson, what you got?
Wait, which question are we on? Sorry, it's been glitching like crazy.
Yep, well, you got that right. So, how about you, Mia? What's the third theorem? Hello, Mia. The third one is angle side angle. Okay. Now, so that means we have this angle and this angle and this side, the side between the angles are congruent. So those two are congruent. What's our fourth one? Hello, Grayson. Hmm. Grayson dropped out. Mia, what's your answer for the fourth one? So the fourth one is a special case, basically is based on the third, angle, side, angle, which is angle, angle, side. So if you have two triangles, if this angle is congruent to this angle, and this angle is congruent to that angle, then the other side really doesn't matter. It could be here. Yeah. Now, if it's here, then we got angle, side, angle, but it's outside, it's here and here, and that still works because the three angles add together has to be 180. So this angle is congruent too. So therefore, you actually get angle, side, angle. So the only thing we don't have is we don't have side angle. Okay, side angle doesn't work. So you can see that if you got just one side, another side, and the angle is here, then that doesn't work. If angle is here, then it doesn't work. Good, because this one could be here, make the same angle. Okay, so side, angle, side, that doesn't work. Okay, good. Good, Mia. All right. Grayson, you good?
Yeah.
Yeah. What is our fourth? Oh, we already talked about the fourth one, which is angle, side, angle. That is special case of angle, side, angle. Okay, now I want you guys to write polygons, okay? The name of the polygons and see if you can remember. Well, we have triangle. That's easy one. Four sides. What do we call them? Yep, very good, Mia. Looks like Grayson, you good? Glitch again. Okay, how about five sides? Five sides. Four sides, we know.
Quadrilateral.
Yeah, quadrilateral.
Goldie, stop. Goldie, stop.
Okay, five sides, okay? You can just type in, what do we call them? And we know there's a famous place for that. Yeah, very good. So five sides is pentagon. Six sides. Hexagon, very good. Hexagon, you can see there is always an A here. AGON, AGON, seven sides. Hello.
Hi, sorry, it keeps kicking me.
Yeah. All right, we're talking about seven sides now, okay? How do we call seven sides? Yep, it's called heptagon. Eight sides? Octagon. And nine sides. Yep, it's Nolagon. Kind of like November.
Nonagon.
Yeah, kind of like November. So October, November, and 10 sides.
Oh, Desungon.
One thing about December, but we don't call that. Yeah, it's Decagon. DACA, Decagon. All right. 11 sides, a little bit tricky. And we actually use U2L1. Yep. Okay, 12. We should know 12 sides. Yeah, was 12 sides. Yeah, is Dotagon. Dotagon. Very good. Okay, that's all we have for today. I'll send out some homework for you to do. Okay. Yeah. Well, bye. Well, we won't have class next week because it's a Thanksgiving week.
Thank you.
So we're going to take a break. Okay.
Bye.
All right. Bye.
Okay.
Bye.